So first, for those who aren't familiar with the topic, RSA is a modern encryption technique that utilizes a pair of digital keys to provide confidentiality and authentication for digital transactions. In today's demonstration, we will look at how Bitcoin takes advantage of the RSA algorithm using a simple program that I wrote in Python, and I'll follow up with a real-time demonstration of that program. So say, for instance, we have two people who wish to exchange some amount of Bitcoin. In this case, we have Jake and Marco. And as you can see, each person has a wallet with an address and some existing amount of coins. The first step in the process is to specify an amount for one person to send to the other. Here, Jake attempts to send 7 coins, but as we saw in the previous slide, he doesn't have that much. And the program tells him to send less, and after doing so, the exchange will start. And now, this is the part where RSA comes into play. Jake's wallet will use its private key to digitally sign the transaction. And it's important to understand that in asymmetric encryption, when something is signed with a private key, it can be verified with the same person's public key. This is useful in authenticating that someone is actually who they say they are. With our transaction request signed and posted on the blockchain, in short time a miner will pick it up and use computer processing power to calculate a hash for the transaction. And if you're not familiar with it, a hash is just a unique alphanumeric string that represents some data. In this scenario, our data is the details of our transaction. Hashes are a way that blockchain can mitigate fraudulent and suspicious activity, because even a small change in the transaction details would result in a drastic change in the hash value. And since the blockchain is being monitored by hundreds of thousands or even millions of nodes at one time, it is impossible for something like that to go undetected. And with that, the transaction is now complete and is available for the world to view on the blockchain. Now I will demonstrate the program. Okay, so here we are in Visual Studio. I'm going to go ahead and start the program. So again, the first thing that it asks for is an amount to send. We'll send 4.67 Bitcoin. And from here, it's going to take a moment to verify that the specified amount exists in our wallet. And once it's verified, we will sign the transaction using Jake's private key. And again, after we do this, anyone with his public key can verify that it's his transaction. The mining fee and hash are then calculated. And once this is done, the transaction is posted on the blockchain and is available for the world to see, and we can verify that Margot received her coins. That concludes the demonstration. Take care, and thank you for watching.